All right, for this problem, we're going to solve an AC circuit that has a resistor and a capacitor. And what we want to determine is what I of t is. All right, so the first thing that we want to make sure is that we have our voltage source in terms of a cosine rather than a sine. All right, so our initial thing is 12 sine omega t minus 45 degrees, and we want to convert that to a cosine. So we are going to subtract 90 degrees. So our new Vs of t is going to be 12 cosine Okay, now that we have that, we can immediately put it in phasor form, and Vs is going to be 12 negative 135 degrees. Okay? All right, now we want to get our circuit in terms of impedances. And so we know ZR is just going to equal R, which is the square root of 3 times 10 to the 3. And we know that ZC is going to be 1 over j omega c, which is going to be 1 over j 10 to the third, 10 to the negative 6, and that's just going to equal negative j 10 to the third. So just a quick reminder that 1 over j is the same thing as negative j. Okay, so now we have our circuit in terms of impedances, all right, and we can write the KVL equation for this loop. So we're going to have minus Vs plus I ZR plus I ZC is 0. We solve for I. That's going to be Vs over ZR plus ZC. Now we can substitute in what we have in order to determine what I is. And that's going to leave us with 12 negative 135 degrees. And then we're going to add ZR and ZC. Okay, so that is our equation for I, and what we're going to want to do is to take these rectangular coordinates and turn them into polar form, because it's much easier to do multiplication and division in polar form. Okay, so now as a reminder, I have I is 12 negative 135 degrees, square root of 3, 10 to the third, minus j, 10 to the third. And I can turn this into polar coordinates, and it's going to be 12 negative 135 degrees over 2,330 degrees. Okay, now I can divide these, and I can subtract those to end up with 0.006 at negative 465 degrees. Now, I always want this angle when I'm dealing with phasors to be in between negative 180 and 180. So if I'm describing the league-lag behavior, I always know what I'm really referring to. And so I is going to be 0.006, negative 465 plus 360. And so I end up with 0.006, negative 105 degrees. Now I want to take this phasor and I want to put it back in the time domain. So I of t is just going to be 6 cosine omega t minus phi milliamps. Okay.